Hello, my brother on dogs. Hello.
All right. Hopefully Cassidy, Stephanie, and Divine can get to these later because I'll post them on Schoology. Today we're discussing solubility, which is effectively how much will dissolve. Okay. So the big idea here is the different factors that affect how much will dissolve. So here are our objectives. So copy these down real quick. Solubility is the amount of solute that will dissolve in a given amount of solvent.
Did you write this down?
So solubility is the amount of solute or solid that will dissolve in a given amount of solvent. So the solute is the substance that you're actually dissolving, and the solvent is the liquid that you're putting the solute into. So like if you think about salt water, if you make salt water, you add salt to water. The solute is the salt. The water is the solvent. A lot of the stuff that we're going to talk about in chemistry, water is the solvent, and they call it the universal solvent because it dissolves a lot of things. It won't dissolve everything, but it will dissolve a lot of different substances. So moving forward, we're going to be reading graphs and doing a lot of graph interpretation. So, and you guys are going to want to write this down. You don't have to copy down the graph. I'll give you guys a copy of that in a couple minutes. But solubility depends on the substance, temperature, and how much water there is. And this is going to be an important exercise in graph reading. So, going on, pay attention, eyes up here. So solubility is like an empty classroom. So it's kind of like how many students you can fit in a class. The bigger the class, the more students they can attend. So that's what we kind of want to consider solubility like. When we're calculating solubility, we're just calculating the number of seats in a class. And if we have more water, we can dissolve more stuff. You have a higher solubility. Okay? So, what you want to get is this second point down here. That's what, Antonio, eyes up to the board. So, let's take a look at this graph for a minute. Look at this graph. Gabby.
I'm looking.
So, consider this graph. We have to look at the axis. This is a solubility curve. So, the vertical axis represents how many grams of solute can dissolve per 100 grams of water. Each substance is represented by a line. And the changes in solvent temperature will affect how soluble the solute is. So normally the trend is that if you have a higher temperature, the more will dissolve. And something that'll help you guys remember that is think about your iced coffee versus your hot coffee. If you put sugar in your coffee, what happens to the sugar when you put a couple sugars in iced coffee?
It stays at the bottom.
It stays at the bottom. It doesn't dissolve. Because at a low temperature, solids have a low solubility. What happens to the hot coffee? What's that? The sugar not melts, but dissolves. So the sugar dissolves because at a high temperature, you have higher solubility. Okay? So these are a couple important things. So moving forward, let's take a look at this first bullet point only. So the solubility of KNO3 at 40 degrees Celsius. So first thing we have to look at the line. We're talking about KNO3. Next thing, 40 degrees Celsius is the temperature. So we get this point, and what we can get here is 60. Now what does this number 60 mean? How would we figure that out? What that point means? Yep, 60 grams of KNO3 dissolved in 100 grams of water. So that's what this point means. Then we get to our second bullet point. So at 40 degrees Celsius, if I have 100 grams of water at 40 degrees Celsius, I can dissolve 60 grams of KNO3. What about 200 grams of water? How much could I dissolve in that? I could dissolve 120 because I have 2 times 100 grams of water. What about 50 grams of water? I could dissolve 30 because I have half that amount. So I want you guys to take a minute, and I want if you guys can figure out the solubility of KCl in 10 grams of water at 70 degrees Celsius. So take a look at the substance, the temperature, and the amount of water. Right now we're talking about this line right here, the KCl line. Right? Talking about this KCl line right here. Let me just talking about this line right here, and I'll select a different color real quick. We'll go with, all right, that's too close to red. All right, so we're going this line right here, KCl. That's my substance. Each substance has a line. My temperature, 70 degrees Celsius. So let's pick another color for that. Anybody want to pick a color? Quick.
Purple.
Purple.
Can we have a burnt crisp orange?
Purple, so you have 70 degrees Celsius. So I'm talking about the KCl line at 70 degrees Celsius. I get a point about right over here. What do you guys think? What do you guys estimate that point is? 48. So we get this point right here. 48 grams of what? What solute am I referring to? KCl. Per what? Per 100 grams of water. Yep. So I have 48 grams of KCl per 100 grams of water. So how many is that in 10? 4.8 grams of KCl. So if I had 10 grams of water at 70 degrees Celsius, I could put a maximum of 4.8 grams of KCl. That's how much I could dissolve. So that's what solubility means. So I want you guys to try this example right now. It's a quick one. It's pretty easy. We're going to do a couple of these. So go on. So let's consider a couple things here. So I'm talking about the solubility of KNO3. That's the first thing. Tony, look here. So I'm referring to this line right here, the KNO3 line. I have a lot of different points on here. How do I know which point we're going to use, Gabby? What do we look to? Really? Am I going to use this point?
No.
Why not? Why not? What's true about this point? The temperature. What temperature are we referring to? 20 degrees Celsius. Good. So I have 20 degrees Celsius. So I want to go up here and interpret my point right here. I get a point. What do I say? What do we estimate it at? Probably 30 or 31. So my solubility is, let's say, I'm just going to say 30. It could be 31 or even 32, depending on how you read the graph. 30 grams of KNO3. That's what we get, right? What other thing? 30 grams of KNO3, what? For 100 grams of water. That's a big deal. How many grams of KNO3 would that be for 500 grams of water? Well, I have 500 grams of water, so it'll be about 150 grams of KNO3 that will dissolve. Okay? Does that make sense? So this point, guys, this solubility, key thing is here, where do we get that point from? We get this from the graph. We look at the graph to get this, and then we consider how much water we have, how much solvent. All right, so we're moving on. These are the degrees of saturation. Now, you don't have to copy down the points here, the dash points. What you do need to make sure you copy down is the bullet points, okay? So the bolded bullet points, saturated, unsaturated, and supersaturated. Unsaturated, Gabby, one more word, that's your last warning, okay? I'm trying to record and you interrupted me.
No, I didn't.
Okay, I'll have this recording down, and we should bring it down, all right? An unsaturated solution is a solution that has less solute than the solubility. The solubility, guys, remember, is like the number of seats in a classroom. Okay? Saturated, so if it's unsaturated, it has less people in than seats. So it has still seats that are open. Okay? Saturated means that is equal to the solubility. So that's like if every desk contained one person, that would be a full classroom. Supersaturated would mean like you had more people than desks. So if we had like 30 students in this classroom, but we only had 25 desks, we'd be over full. The only way to do that is by cooling a saturated solution. That's the only way we're going to see that. Normally, we're going to talk about saturated, unsaturated, maybe a little bit supersaturated. So moving forward, this here, so solubility represents how much can dissolve. It's the maximum amount that you can put in, and it will dissolve. So saturated, every kid has a seat. Every student, there's a seat for, and they're all full. You can't fit any more. Unsaturated, there's seats open. You can still add more students to that classroom. Supersaturated means there's so many students, but all the seats are already full. It's overcrowded. So that's how I like to relate solubility. We're almost done. So let's finish up this last couple of things. So problem solving, guys. This is the last thing. When we're problem solving is this, we need to find the correct solute line.
Can I try the wrong one?
Yes. And then calculate the solubility. Remembering to consider the amount of water. That's a huge point right here. And compare the conditions you're given to find your solubility. Okay? So this is the homework. It's not so bad, guys. It should be pretty easy. So we're going to really need to keep on track this next 2 weeks, guys. Okay? Just bear with me. I think after the mid-year exam grades, guys, we did okay, but I still think we can do better. Does everybody have a copy of the homework? Do you guys have a copy of the homework? Okay.